agranulocytes are the second category of white blood cells. Now, I've already gone through the granulocyte category, which that was neutrophil, eosinophil, and basophil. Now we're looking at the category of agranulocytes, which are monocytes and lymphocytes. Now, the agranulocyte, that prefix A, means without granules. So you're looking in the cytoplasm of the two cells. You're going to notice there isn't anything in the actual cytoplasm around it. There's no visible granules. So the first up is the lymphocyte. Now, the lymphocyte is give or take about 25% of your white blood cells. You'll notice this is your lymphocyte. It's a little bit bigger than a red blood cell, but not much. It's going to have a very dark nucleus, but this nucleus takes up almost the entire size of the cell. All you have is a very thin rim of cytoplasm around it. There are three main types of lymphocytes. There is the T lymphocyte, also known as T cells. These T lymphocytes, or T cells, are going to help with your immune response. The B cells, or B lymphocytes, these B cells are dealing with antibodies. Now, it doesn't have a direct path to antibodies. The B cells make up these plasma cells then. The plasma cells then give rise to the antibodies. So your B lymphocyte makes the plasma cells. The plasma cells then make the antibodies. And remember, antibodies are what recognize cell surface markers, whether they're your own cells or foreign cells. The third is going to be the natural killer cells. These natural killer cells are going to recognize any cell that does not have the self marker. So the cell surface marker, or antigen, basically that says this is part of your body. So anything that doesn't have that, could be bacteria, could be virus, whatever. Anything that doesn't have it, the natural killer cells can destroy. So we have the B lymphocyte, the T lymphocyte, and these natural killer cells. So throwing this up to full screen, you'll notice this is your lymphocyte right here in the middle. You can notice that the edge right here can see just a little bit of cytoplasm. Otherwise, it's pretty much a smooth edge all the way around. Now, if you're thinking, how do you identify this compared to a basophil? You can identify a lymphocyte compared to a basophil because a lymphocyte, the outside cell surface, is smooth. The basophil had those bumps from the granules on the outside. Plus, you can see all the granules all throughout the cell being very dense. But if they both just look solid purple, look at the outside edge. If it's smooth, lymphocyte. If it's bumpy from granules, that's a basophil. So this is your lymphocyte. Monocytes, the other of the agranulocytes. The monocytes I have here 4 to 8%. Again, don't memorize the exact percentage. Just know it's lower than the lymphocyte, lower than the neutrophil. This is the largest. Look at the size difference. Look how big that is compared to the red blood cell. So the largest of the white blood cells. Now, these monocytes can leave the circulation and turn into macrophages. Now, macrophages are going to be vitally important in your body because they engulf, they eat, they destroy whatever shouldn't be there. Whether it be foreign particles, bacteria, virus, whatever, whether it's dead and dying cells, whether it's just simply dirt and debris, it doesn't matter. The macrophages will destroy it. Now, if you have a high count of these monocytes, that means you've had an infection for a longer duration, so a long-term infection. Because a very short-term infection, right at the beginning, you had a high count of neutrophils. But if the infection progresses, then the monocytes can increase their count number and you have a high count later in the infection. So a high monocyte count means a long-term infection. So blowing this up to full screen, what you're seeing is the monocyte is right here in the middle. Notice the nucleus does not take up the entire full size. Instead, you have the nucleus taking up maybe 2/3, 3/4. I kind of like to think of this more as Pac-Man. Pac-Man is meant to go out there and eat, eat, eat. These monocytes will go out and eat and eat and eat. And that nucleus kind of looks like Pac-Man a little bit. You can almost see it as the structure here. So you kind of have the little idea of Pac-Man kind of chomping and eating there. So the idea is you're looking at your monocytes. This is the second of the agranulocytes with the lymphocytes. Now, a word of caution, since I just mentioned the whole idea of monocyte and lymphocyte. Lymphocyte, you have to be careful, is one of the cells of the category leukocyte. Leukocyte means just white blood cell in general. So a way to kind of think about this is you can actually think about it and say, all right, a lymphocyte is a leukocyte, but not all leukocytes are lymphocytes. Like, what am I talking about? Leukocytes have 5 different types. White blood cells, there's 5 different types. But every lymphocyte is a leukocyte. So just keep it straight. Leukocyte, the category of all 5, lymphocyte is the actual one cell of the agranulocyte category. All right, back to the macrophages now. Now we know macrophages are going to eat and destroy. They are very mobile and very phagocytotic. They're going to search out and destroy anything that should not be present in your body. But they can also then activate the lymphocytes. So they find an infection, these macrophages find an infection, they can then send word back to those lymphocytes. Say, hey, get the immune response going. We've got an infection here. So they're basically like those first responders of what's finding inside the tissues. All right, how do we make these again? We've already gone through a previous video, the rough outline of how to go through and make all the different formed elements. But let's focus a little more on the white blood cells. Leukopoiesis is the formation of these white blood cells. Formation of all 5 of them, for that matter. You're going to use the interleukins. Interleukin 1, interleukin 2. They're going to help stimulate the actual promotion and development of these white blood cells. Now again, remember, they're coming from the red bone marrow. They're coming from that initial hemocytoblast, that first stem cell, that then differentiates into different paths depending on which white blood cell you're producing. We also have the colony stimulating factors. Now these colony stimulating factors are named specific to the white blood cell they produce. So for example, you'll have a monocyte colony stimulating factor. You'll have a neutrophil colony stimulating factor. So you have these specific ones. They know which individual cell needs to be produced. And again, every one of these originates from that stem cell, that hemocytoblast, or that hematopoietic stem cell. So you're coming from the initial one, then differentiating into each individual type of the 5 white blood cells. All right, we've seen this. Let's blow up full screen again. Remember, you start with the hemocytoblast and either go down through the lymphocyte side. So that's the lymphoid stem cell, the lymphoblast, and heading down either then into the natural killer cell or the small lymphocyte, which is the T or B cell lymphocyte. That's one pathway. The other pathway is heading down to the myeloid system, then either monoblast or myoblast. In the case of the myoblast, simply goes to monocyte. But then if you're looking at the myoblast, you either go basophil, neutrophil, or eosinophil. That's dependent on the colony stimulating factor. So whichever colony stimulating factor is there stimulates which white blood cell is growing. So we have these different pathways. We now know that the white blood cell can either be one pathway through the lymphocyte one pathway monocyte, or one pathway that's all three of the granulocytes: neutrophil, basophil, eosinophil. So how about some disorders, unfortunately? Leukemia is one of the disorders of the white blood cells. Now, leukemia is about immature white blood cells. So what's happening here is you're still producing white blood cells, but as they're being produced, they're not fully maturing, which means they cannot serve their purpose. So you have tons and tons of white blood cells. They're just not working. So the bone marrow that's producing the white blood cells becomes completely occupied with cancerous leukocytes. So those stem cells they're producing, well, those leukocytes become cancerous and brittle, which means they're still producing and producing and producing, but they're not functional. So unfortunately, that means they can't do their job. So the white blood cells they're produced just don't do anything. They're not functional. Which means, unfortunately, these individuals, if they do progress without being able to go in remission, if they do progress through the whole disease, death will occur because of usually internal hemorrhaging from overwhelming infection. That's simply because the body cannot handle itself. Basic infections cannot be removed because the white blood cells are not functional. Now, there are treatments, irradiation, and leukemic drugs, bone marrow transplants. And for some people, this works. The disease then recedes, it's gone or in remission, and the person can live a relatively normal life. But again, it has to be treated. It cannot just simply be ignored. Otherwise, the cancer will keep on grow and grow inside the red bone marrow there. So this is a histology view of leukemia. All the purple cells are white blood cells. Now, if you're saying, hey, that's good, there's a lot of those. Here's the comparison. That's a healthy blood sample. Same size cells, same amounts of space. Look at the sheer number of white blood cells in this leukemic slide. There are so many cells, but they're just not functional. They can't work, which means they're not doing their job. They cannot fight off infection. So just because they're there doesn't mean it's a good thing. So leukemia, high amounts of white blood cells that are not functional. So those are the agranulocytes, the monocytes and lymphocytes, as well as a little bit about how leukopoiesis works and some disorders.